that, and it comes out about 0.48. Okay, yeah, we can interpret that.
Would it be negative 4.8?
Yeah, well, that's what I said originally, but then I didn't like it, and it would be negative 0.4 seconds. No, it's plus, never mind. I'm just being ignorant. What I wrote down was right. Okay? Okay. Now, the interpretation of this is that if you had a projectile that started down here at the floor, or started down here somewhere, yeah, at the floor, 1 meter below this, it would go up like so, peak here, and then be past its peak, so it's going down at 37 degrees at this point. And that would occur 0.48 seconds before this instant, right? The equations don't know. I mean, if you had a problem, a projectile is projected from here and lands over here, okay, and passes this point at 37 degrees below horizontal at 60 centimeters per second. Then when did it, how long did it take to get there? Okay, you could say, well, let t equal 0 here. This occurred at negative 0.48 seconds, so it must have taken 0.48 seconds to get here. And then another 0.44 seconds to get here. Or 0.4 seconds, okay? That makes sense? Okay, so at 37 degrees, you actually get to 0.4 seconds. I didn't know that was going to happen. I just chose 37 degrees because it's an easy angle. But the other thing is you were nowhere near 37 degrees, so all the times of fall that you used to do your calculations are a bit short. But now you see what to do. Now, the harder question, much harder question, and I don't have time to go through it in detail, because it takes a little thinking, but we'll talk about it next time. Is to figure out how fast the ball was actually going for each of your observations. Okay? So, here will be the problem. If the ball travels, what? Okay, 50 centimeters in a horizontal direction. Okay? Initial angle 6 degrees. How fast was it going? At the edge of the ramp. Okay? Well, you can see that your R of t function, the edge of the ramp is still going to be 0, 0. So R of t is going to be v naught t. I want to be consistent with my notation so it doesn't get confusing. And that would be Vx of 0. I use dx subscript. So you'd have this, right? Now, what you don't know is you don't know Vx or Vy, and you also don't know T. There's three things you don't know. And you've really only got two equations. At the floor, okay? You can set this equal to this, but you don't know Vy or T. So, not knowing Vy or T here isn't going to help you. If you knew T, you'd be able to find Vx, because actually at the floor, this is, we do know Vx. 0.5 meters times I minus 1 meter times J, right? So we have a couple of equations here, but we have three unknowns. This will give us two equations in the unknowns, Vx, Vy, and T. Okay? How do we get out of that? Well, we know the A. So, I want to be careful. I don't want cosine of 6 degrees. I want the cosine of 354 degrees and the sine of 354 degrees. Because this angle's clearly below horizontal. Sorry? Pardon?
Never mind, I figured.
Okay. Figured you would. I just played dumb for a minute.
Oh, thanks.
I find it easy to do that. Okay, so we have this, right? So now our two equations have only two unknowns. V0, V of 0, and whatever that other unknown is, T, right? So now we have only two unknowns. We get there's a T in there. And of course, cosine of 354 degrees and sine 354 degrees. Just plug those angles into your calculator. You get about 0.1. So and that's not 0.1, that's a .995, and then negative 0.1, P of 0 T minus 5 meters per second squared T squared equals negative 1 meter. Okay, that's what the numbers are actually about. It's still not totally trivial to solve it. Okay? So I'm going to ask you to do that for a couple of your observations. Figure out what the initial, the velocity at the end of the ramp you concluded was, using the 0.4 seconds, and then figure out what it really was. Okay? And really, you know, if you'd have figured it out from the horizontal velocity, it would have been 0.44 seconds. So it would have been about 10% less than what you got. So, you know, we want to make those comparisons. Does that make sense? There's your scheme. That's your whole scheme for projectile motion. And this is probably the hardest type of problem. Now, there are others where, you know, I throw a ball from here at some angle, and it hits the wall over there at some point higher than where I threw it. But you set it all up using this RT function. And that's what I really kind of want to see. I don't want you to see just going to, okay, here's the X motion, here's the Y motion. Although that's good too. I want you to do it in the more general context. Fair enough?
Mm-hmm.